Good afternoon to everyone who's watching this program. Before we start, we would like to welcome you. We know we're coming from the vacation. Some of you has relaxed a little bit, and some of you have been working throughout the vacation. I want to tell you, matriculants, that your hard work, when you're working throughout the vacation while your friends were playing, will play out at the end of the day. Before I can start with the topic for today, as you might know that we are doing calculus today, basically the application of calculus in cubic functions. I would like to know whom are we with in this program. Teachers, can you please participate with us through our social media, WhatsApp us, tell us your name. If you are Miss, if you are Mr. Mr. So-and-so, the name of the school and the province where you are watching the program. As you might well know, today we are doing calculus, cubic function, as you can see on the screen. You may be wondering, learners, that why now that we are doing cubic functions in grade 12, why didn't we start with cubic functions in grade 10 or grade 11? It's simply because you didn't have enough material or resources or tools that you can do cubic functions. First of all, we need to know how to factorize cubic functions, not the simple factorization that we did in grade 10, whereby we were doing the sum and the difference of two cubes. Now you have to know how to factorize the cubic function in general. Secondly, the cubic function has got the maximum and the minimum. In order for us to know exactly where it will attain that maximum and the minimum, we needed calculus. So you didn't learn calculus in grade 10 and grade 11. So now, since we know calculus, then we can do cubic functions. But before we can do so, we know that the head list in doing cubic functions, first of all, is to factorize the cubic function. So the natural way of understanding factorization is from doing the division. For instance, from numbers we learn, if you're having 17, and the 17 you have to divide it by 3, and then we know that the answer 3 goes to 17 5 times, but there is a remainder. What is the remainder? Is 2, then we write 2 over 3. That simply means that we can write 17 as 3 times 5 plus something, which is our remainder. So if we're having a situation like this, then that is another way of writing 17. But we are looking for a way in which this remainder will be 0. For instance, if now we are having 20, and then 20 we divide it by 4, and we know that 4 goes to 20 how many times, learners? Yes, goes there 5 times. That means 20 can be rewritten as 4 times 5, and there is no remainder. If we are having a situation like this, we can say now 4 is a factor of 20 and 5 is a factor of 20. So this kind of knowledge that we learn from numbers, we can generalize it and take it to algebra. All the things that you are learning from algebra most of the time is the generalization of the simple rules that we've learned from numbers. Now, some important things to remember. If we are generalizing what I've just discussed with you now, for any polynomials, f of x and g of x, there exist two other polynomials, say qx and rx, such that then you can write f of x in the similar fashion like this. This is the same as the first example that I did with you when we wrote 17 as 3 times 5 plus 2. So our remainder here is rx. Again, if rx is equals to 0, then we have f of x equals to f of x equals to g of x times q of x. Now this g of x is a factor of f of x and qx is a factor of f of x if the remainder is 0. Then that's our remainder theorem. We're having our factor theorem. Again, learners, there's something also that comes in handy, which is a variant of the remainder theorem. Let's say we're having this polynomial there. I know that you know how to generalize a polynomial. You can reverse it. Now we're having a linear polynomial ax minus b. Now we're having a remainder theorem, a variant of the remainder theorem, which cut our work in half. Let's say the remainder when f of x is divided by g of x is given by. We know, learners, that I think we have been introduced to long division method, synthetic division method, but if you are interested to find only the remainder, you need not to do any of those methods. This theorem just gives you the remainder, then you can do this. So, the remainder, when you are dividing f of x by g of x, it can be given by f at b over a. Where is this b over a coming from? Remember, learners, we have g of x equals to ax minus b. And then if you let g of x there to be equals to 0, now what we'll end up with, we'll end up with that ax minus b equals to 0. Taking b over minus b over, we'll end up with ax equals to b. Then we can solve for x there by dividing by a on both sides. Then we end up with x equals to b over a. That is the b over a we are having in there. Now, taking this a step further, now we're going for the factor theorem. What the factor theorem is saying, if f of x is a polynomial such that f at b over a is equals to 0, remember, this f at b over a is the remainder. Now, if the remainder is 0, then the conclusion says ax minus b, which was our g of x, that the polynomial that we divided with. Ax minus b is a factor of f of x. Another way of saying it, if f of x is a polynomial such that f at a is equals to 0, then x minus a is a factor of f of x. It's still the same thing that we have said. Let's just apply this information quickly with this example. Determine when f of x equals to 6x cubed and all the way is divided by g of x equals to x minus 2. Now we want to determine the remainder in this situation that we have there on the board. Let's just quickly do that, learners. Can you just do it quickly and finish it even before I do it so that you can see how far did you understand what we were doing. So what we are given there, we're given f of x equals to 6x cubed minus 4x squared plus x minus 8. And our g of x is equals to x minus 2. Now, according to the remainder theorem, it says that we can find the remainder by doing, we can let the g of x be equals to 0. If we do so, we end up with x minus 2 equals to 0. Taking minus 2 over, we're having x equals to 2. Now, we will do f at 2. We substitute that in our original polynomial, then we end up with 6 into 2 cubed minus 4 into 2 squared plus 2 minus 8. I believe that you can easily work this out, learners. The remainder will end up being 26. That simply means that when we are dividing f of x by g of x, if we are interested on knowing the remainder, then we just let the g of x equals to 0 and substitute the 2 there, and then we know that the remainder is 26, meaning g of x is not a factor of f of x. Secondly, we're having this question there, show that x plus 3 is a factor of that polynomial there. So our expectation, once they say that it is a factor, that means we are expecting that the remainder should be 0. Let's see if the remainder will be 0 in this situation. Let's give that expression a name. Let's say it's f of x. Our f of x this time is minus x cubed minus 4x squared plus 3x plus 18. Now, we say let x plus 3 equals to 0. Now, taking 3 over is going to be negative 3. And then we do f at minus 3. If we are substituting minus 3 into f of x, we're going to get minus 3 cubed minus 4 into minus 3 squared plus 3 into minus 3 plus 18. That's what we have. Punching that in our calculators or working it out by inspection, you can easily see that the answer there will be definitely 0. So then once the answer is 0, we can do the conclusion. We can say since f at minus 3 equals to 0, then therefore x plus 3 is a factor of f. So most of the time, learners, they do this mistake of just substituting the minus 3 into the function, and they get the answer equals to 0, and then they don't do the conclusion. It is important to conclude, learners, because that's exactly what you were asked to do, to show that the g of x or the x plus 3 is a factor of f of x. Now, continuing from there, we know that there are formulas that we did in grade 10. What we have on the screen there is the difference of 2 cubes. That's what we have. We know that those formulas that we learn in grade 10, that's how you factorize the difference of 2 cubes. If it comes to an exam, it's not expected of you not to know this formula. Secondly, the sum of 2 cubes, How do we factorize the sum of two cubes? That's how we factorize. I'm not going to go into details with this because this is something that you've done in grade 10. Now, that is the cubic function now in general. All the terms are there. How do we easily factorize it? That is an expression. If you can write it in that expression, then it becomes easier for you to factorize it further. Now let's look at these examples. It says there, fully factorize. Now, first of all, we're having that difference of two cubes. I believe that you can see that is the difference of two cubes. Let's quickly factorize that difference of two cubes. And then if we express these numbers as cubes, you can write it this one as 2x to the power 3 minus 3 to the power 3. According to our formula, this can be rewritten as 2x minus 3 into 4x squared. We square the first bracket, it becomes 4x squared, and then we take the product of these two, and then it's going to be 6x, and then we square the last one, plus 9. So that would be the factorization of the difference of those two cubes. Secondly, we're having that expression there is x cubed plus x squared minus 6x. Now you can see quickly here easily that if we factor out x is a common factor, if we factor x out, then we'll end up with x squared plus x minus 6. But the instruction instructed us to factorize fully. When you are here, you are not done as yet. We can factorize this trinomial. It's a quadratic trinomial. We can factorize it further by having two sets of brackets. It's x there. And then what are the signs? Since we're having a minus there, we'll be having a minus and a plus, or a plus and a minus. So the factors of 6 that will give us our middle term is when we're having 3 this side and we're having 2 this side. So in doing so, we have fully factorized this polynomial. Now we're going for the third one, which is the full cubic polynomial. So we have to factorize x cubed plus 4x squared minus 3x minus 18. Now, first of all, we'll need to find the first factor. Remember, in the other example, when we were asked to show that x plus 3 is a factor of a certain polynomial, is the same as this polynomial that we're having in here. So we're having our first factor as x plus 3. Is our first factor here. So we will need to find the quadratic expression of this. So now we ask ourselves, what do I multiply with x to get x cubed? Obviously, it's going to be x squared. Now, the middle term here, I will keep it for now as kx, and then I will have to find the value of k. Now, the next thing, what do I multiply 3 with to get minus 18? I'll multiply it with minus 6. Then we have to find the value of k. Now, to find the easy way of finding the value of k is just to multiply this out and take the terms with x squared, and then compare those terms with x squared with the term with x squared in the main in the original polynomial. So if we multiply 3 with x squared, we'll be having 3x squared. Again, if we multiply x with kx, we'll be having kx squared. Now, if we compare the terms with x squared with the term with x squared in the polynomial, is 4x squared. Now, taking this over, we'll be having kx squared is equals to 1, or x squared. Then dividing on both sides by x squared, we're having k equals to 1. So now, learners, this simply means that this is x plus 3 into x squared plus x minus 6. Now we can factorize this further by saying x plus 3 into, now we're having x, it still comes back to what we've done earlier there. So it's going to be x minus 2 and x plus 3. Can you see, Lena? So that's how we factorize the cubic polynomials in general. Now let's come to another tool that we need in cubic function. Now we are applying calculus to finding or drawing the cubic function. What is calculus telling us? What does f prime of x tells us about f of x? First of all, the interval where f is increasing or decreasing. For instance, if f prime of x is positive, then f of x is increasing on that interval. Secondly, if the derivative is negative, then the function is decreasing on that interval. Secondly, what the first derivative is can tell us about the function where we are having our local max and our local mean. So we equate the derivative to 0. That would be an expression for the local mean max and the other one for the local mean. Now, the person who have introduced this was my favorite mathematician, Pierre Fermat, who postulated that if you're having a line or a tangent line to the turning point or to the local max, then it is horizontal. That line, then its gradient is 0. Same applies if we take that line and we throw it to the local mean there, its gradient will be 0 because the gradient, remember learners, the gradient of a horizontal line is always equals to 0. That's what Fermat assisted us then. That is having a lot of application in mathematics. If we look at this again, so we're having those two lines there, both one is at the turning point there. So you can see that line is strictly horizontal. So we call that's a stationary point. How do you find that stationary point? By doing the derivative and you equate it to 0. And we call it a local maxima. Remember, learners, it cannot be a maxima because we know that this graph, if you can see there, it extends. That means it doesn't have the absolute maxima, but it does have the local max, which is that part there. And again, at that point there, we have a local minima. How do we find it? We do the derivative and we equate it to 0. Now, the other thing that the first derivative is telling us, can you see? If you draw any tangent line to this curve at this point, it will be lying to the right. All the lines with that are lying to the right, their gradient is always positive. What does that tell us? If your derivative is positive, then that means the function is increasing on that interval. Same applies on that side. If you're drawing a tangent line to this side, its gradient will be negative. So if the gradient is negative, what does it tell us? That the function is decreasing on this interval. From the turning point there up to there, the function is decreasing. Again, if you draw tangent lines there or the gradient, you do the gradient of the derivative there, you'll find that the derivative will be positive. That simply means the function is increasing on that interval. Again, we go to the second derivative. What does the second derivative tell us about the function? First of all, it tells us about concavity. First of all, if the second derivative is positive, then f of x is concave up on that interval. Again, if the second derivative is negative, then f of x is concave down on that interval. The second thing that the second derivative tells us about the function, where we have our point of inflection. What is the point of inflection? A point of inflection is a point where the graph of a function changes concavity. And how do we get the point of inflection? By doing the second derivative and equate it to 0. We solve for x and then we get our point of inflection. To explain this further, if you look at this graph, these two illustrations here, that is concavity. Now, if you look at this, you don't need to have a full curve to say this graph here or this shape is concave up. One part of it that shows concave up, and this part here shows concave down. Or you can have a full curve like this in there, that is concave down, and from there is a point of inflection, and that's concave up. I think that will explain it better, and you might understand better how concavity works. The standard form and basic graphs. Now, this is a standard form in general of a cubic function. So it is important to know that if A is positive, then you're having this typical graph. This one is the one that when it does not have all these other terms, bx squared plus cx plus d, when you only have got this part and A is positive, then you'll be having this kind of a graph. When you're having all the other terms and A is positive, it will look like this. So learners, it is important to know this so that when you are doing your function or your graph, to check if A is positive, you must be expecting a graph like that one. Also, if A is negative, so you're expecting a graph like that or a graph like that one. So what are normally asked in cubic functions is to sketch the graph, interpretation of the cubic graph, finding the equation of the cubic graph, also question pertaining the first derivative of a cubic function when it is treated as a function. Sometimes you might be given a graph, but that graph wouldn't be a graph of a function, but of a derivative. So you must be able to work back and forth. Before we start with the example, I would like to see what do we have on our social media, on our WhatsApp. I'm seeing no signal. A message says Masakeke. We can't watch. I think they have sorted out. I believe that if you're still struggling to connect, please call the number that is designated for such problems. Bridgetown High School, they are saying that they are watching. They are with us. Let me see if I can have another one. Hi, I am Fundo from Mary Waters High School. I think you have been too fast. Yes, learners, I will always apologize for that because this is just an introduction. We're still gonna go for the exercises, so I want to save as much time as I could possibly do. I am Kosinati Manono. Would you please explain more application of calculus? That's where exactly we are going now. We're going to do some examples. Just keep on interacting with us, learners and teachers. But I didn't get the name of the schools and the provinces where you are watching. So let's do some examples, the real application of all these things that we talked about. So there's an example on the slide. Just look at the example there, learners, and just think about it I will give you just few seconds to look at it, and then we'll do it together. Okay, learners, if you look at this example, you can see that we are told there, we are given the function f of x equals to 2x cubed minus x squared minus 4x plus 3. That is the function that we are given. It's a cubic function because the highest power is 3. If the highest power is 2, then it's a quadratic. But this one is a cubic function. Now, 1.1.1 show that x minus 1 is a factor of f of x. When they are doing this now, they are saving you the effort of trying to find that first number that goes there, that makes us that the f of x equals to 0. So we have to, as I have done in the example, that we need to show that x minus 1 is a factor of f of x. What do we need to do, learners? Remember, we let x minus 1 equals to 0. Then taking minus 1 over, we'll have x equals to 1. And then we can substitute this into our original function f of x. Now f at 1 will be 2 into 1 cube minus 1 squared minus 4 into 1 plus 3. Now working this out, this will be 2 minus 1, which is 1. 1 minus 4 is minus 3 plus 3. That's definitely 0. So we have shown that x minus 1 is a factor of f of x, because when we're substituting this into the function, then we get a 0. But this is not enough. We say now, since f at 1 equals to 0, therefore x minus 1 is a factor of f. So we have answered number 1, and then let's go for number 2, 1.1.2. What are we asked also, further learners? Hence factorize f of x completely. Once you hear of the word hence, that means you can use the previous answer to answer this question. So that's where hence comes into play. So we will use it. So we will be having f of x equals to our first factor, which is x minus 1, which is the one that we have just proved now. X minus 1 into, now let's get that expression for a quadratic that will be multiplied by this binomial here. Now what do we multiply x with to get 2x cubed? Obviously, we will multiply with 2x squared. Now we say plus kx. What do we multiply? We ask ourselves again, what do we multiply minus 1 to get positive 3? So obviously, we have to multiply it with negative 3. And then now we have to find the numerical value of k. So if we multiply minus 1 with minus 2x squared, we'll be having minus 2x squared plus. If we multiply x with kx, we have kx squared equals the term that is having x squared in our original function is minus x squared. So we can take minus 2x squared to the other side, and then we'll be left with kx squared equals to minus, this was mine, let me, it's just that I've written this to the edge, or it's minus, so this one will be positive, then we'll be having x squared there. That means our k again is equals to 1, and then we substitute that back there, so we'll be having x minus 1 into 2x squared plus x minus 3. So now we have to factorize this part further again, so we'll be having x minus 1 into, we'll be having two sets of brackets, then this one will be 2x, and this side will be having x. Now, since we're having a minus there, but let's not fill in the signs immediately. Now, what do we multiply? The factors of 3 is only 3 and 1. And then the factors that will work is when we're having 1 this side, so that we'll be having 2 times 1 and 3 this side, because we have to find the difference. The difference should be 1. Now, the positive should be on this side and the negative should be on that side. I believe that you don't struggle to factorize the quadratic polynomial, because that is something that you've started to do since grade 9. So once we get to this point, you can see these two are identical. You can simplify them or write them nicely as follows: 2x plus 3 into x minus 1 all squared. Now, once you have done that, you have fully factorized f. Now, the next question, it's 1.1.3. 1.1.3. Now, what are they saying? Determine the coordinates of the turning point of f. Now, learners, it comes to the application now of calculus. Remember, in those examples that I did, or the explanation that I did with you, that we needed calculus in order for us to know the turning points. What do we do? How do we find the turning points? You have to differentiate the function, you equate it to 0, you solve for x. That x value, it tells you where your function is having the local max and where your cubic function is having the local mean. So the first thing that we need to do now is to find the first derivative. Now, our f of x, remember, was 2x cubed minus x squared minus 4x plus 3. That's our original function. Now, if we're doing the first derivative, is f prime of x. What is f of prime of x? I believe that you have done calculus already. You know how to differentiate a simple polynomial like this one. So it's going to be 6x squared minus 2x minus 4. And what about 3? We know that the derivative of the constant is always 0. So that is the derivative of this function. Now we're gonna let f prime of x to be 0, and then we'll be having 6x squared minus 2x minus 4 equals to 0. Now to solve this now is a quadratic equation. Before we can factorize, we can say that 2 is a common factor. We can just divide each term by 2. So we'll end up with 3x squared minus x minus 2 equals to 0, which will make it easier for us to factorize. So this side will be having 3x, there we'll be having x. Now we're having 2, we're having 3. That simply means that this side we need to have 1, and there we have to have 2, and negative this side, and a plus this side, so that we can have this negative there. So we can conclude to say x is equals to negative 2 over 3, or x is equals to 1. So those are the x values where our function is turning. Remember, our a there is positive. That means our function will be doing something like this. So this one will be our local max, and this one will be our local mean. But in the instruction there, they say determine the coordinates of the turning point, not the x coordinate. So that means we need to find the corresponding y values for both of these points. Now we know already that f at 1 equals to 0 is something that we have done earlier, and then now we only need to do f at minus 2 over 3. So if we are doing the substitution, we'll be remember, learners, when you are doing the substitution here, don't do that mistake of substituting into the derivative. Always substitute into the original function, because once you substitute into the derivative, your answer will be 0. So we substitute into the original function. So let's do the substitution. It's going to be minus 2 over 3 cube minus 2 over 3 squared minus 4 into minus 2 over 3 plus 3. Now we can use our calculators and figure out what is the answer in here. We can quickly use our calculators. Now if I quickly type this, is minus 2 over 3, close the brackets. I close the bracket incorrectly. Let me delete and go out. That is also what you do in the exam. You need to check. And then we're having minus, open the bracket, minus 2 over 3, and out, we close the bracket, we square, minus 4 into minus 2 over 3, again, out, and we close, plus 3. And then the answer is 125 over 27. I believe that you got the same answer, 125 over 27. That is our corresponding y value. Therefore, our turning points now. When x, let's start with a small one, when x was minus 2 over 3, and then we find that the corresponding y value is 125 over 27. And again, when x was 1, the corresponding y value is 0. So those are our coordinates for the turning point. That's where our function will be having the turning points or the stationary points. So we are done with the point where the graph, where our turning points. Now let's go for 1.1.5, 1.1.4. Draw a neat sketch graph of f indicating the coordinates of the turning points as well as the x-intercepts. So with all the information that we have done so far, then now we have enough information to just draw the graph of f. Okay, drawing the graph of f, you can just draw our axis. I believe that you know how to do so. And then we're having x there, we're having y. Most of the time, I always discourage learners to write numbers in the Cartesian plane. Just don't write any numbers. Just fill in the important information, draw the graph, and then later you'll fill in the numbers at the turning points and at the x-intercept. Because sometimes when you are writing 1, 2, 3, and then you find out that your function is turning at 50, where are you going to get to 50? Then you will be having a very ugly graph. Just draw down the important things. And then the first thing that I always tell my learners to start with are is where the graph is turning, the coordinates of the turning point. For instance, in our earlier calculation, we know that our graph is turning at minus 2 over 3, very close to 0. Minus 2 over 3 is 0, minus 0.6666, I believe so. So it's very close to 0. Somewhere there it will be turning, and 125 over 27, just to have a rough estimate of 125 over 7 is 4.6. At 4.6, when y is 4.6, so our graph will be turning there. Then I will always make a cusp like that so that I can finish off my function from there. And also at 1 and 0, when x is 1, our graph will be turning. So it cannot turn downwards like this. Obviously, it has to go up to get there. So this part, we can feel it immediately. Our graph will be going that way. And there, that's how our graph is going to behave. Remember, it's turning there, and then we're having our graph. Then you just fill in the important parts. So the first part that is important is the coordinate of the turning point, which is that minus 2 over 3 and 125 over 27. That is very important. And also there, we're having 1 and 0. We're having the y-intercept. The y-intercept, you get it always by making x 0. If we make x 0 in our f of x, and then we can see that we're having 0 and 3 there. And then we're having this x-intercept that we need to find. Remember, when we were asked to factorize this function, what did we get? When we were asked to factorize fully, we got that this f of x is equal to 2x plus 3 or x minus 1. So the x minus 1 is the one that we have there already. Now, the other x value is when we equate this to 0, then we're going to have x equals to negative 2 over 3. So this part here is going to be negative 3 over 2. This x-intercept will be negative 3 over 2 and 0. So those are the important things that you need to have when you are asked to draw the graph of the function. If you have done all of this, then it guarantees you to get all the marks. Now 1.1.5, for which value of x will f have a point of inflection? So we need just the x value where f of x will have a point of inflection. Remember, learners, we have done our first derivative somewhere. We said our first derivative, that's 1.1.5. Our first derivative was 6x squared minus 2x minus 4. Now, to find the point of inflection, we need to do the second derivative. If we differentiate this further, we'll be having 12x minus 2. And then we equate this to 0, and then we'll be having 12x minus 2 equals to 0, and then taking minus 2 over, 12x equals to 2. That means x is equals to 1 over 6. So that will be our x value, where our function will be turning or changing the concavity. So it will be changing the concavity at 1 over 6. Let's quickly do this example, learners, before we run out of time. Now again, we are given in 1.2 this function f of x equals to x cubed plus x squared minus 5x plus 3. Draw a sketch graph of f of x. You see now here you have been thrown into the deep. It is unlike the first example where you were given everything. You were asked to find the coordinates of the turning points, to factorize the function. But at this stage, you have to do all of this by yourself. So let's do 1.2.1. So the first thing that we need there, we need to factorize f of x. So if we are factorizing f of x, we need the point when we are the number when we are substituting into f, it will make f 0. But by quick inspection, you can see that if you are substituting 1, this expression will be 0. So if we are doing f at 1, it is easy to show that into plus 1 squared minus 5 into 1 plus 3, we can easily show that this is 0. That simply means that x minus 1 is a factor of f of x there. So we can continue factorizing it. What do we multiply x with? It's going to be x squared plus kx, again minus 3. If we multiply minus 1 and x squared, we'll be having minus x squared. X with kx will be having plus kx squared equals to, the term with an x squared in our original function is x squared. That means kx squared is equals to 2x squared, meaning k is equals to 2. So we can further to say x minus 1 into x squared plus 2x minus 3. Now continue factorizing the quadratic trinomial is got to give us x and x. And now we're having minus, so we have to have minus and a plus, or plus and a minus. But the 3 must be on this side and the 1 this side. So we have factorized our polynomial. What we have in here, we're having x plus 3 into x minus 1 all squared. Secondly, that was the first thing that we did. Secondly, we need the point where the graph is turning. So the turning point, we do the first derivative. The first derivative will be 3x squared plus 2x minus 5. We equate it to 0. We'll be having 3x squared plus 2x minus 5 equals to 0. And then we solve this equation. So we'll be having 3x and x. The factors, we have to have 5 this side and a 1 to have the 2 there. So we're having a plus this side and a minus there. So that means x will be 1 over 3, or x will be equals to negative 5. So those are our x values for the turning point. Finding the corresponding y values, we substitute these back into the original function. Then if we are substituting this into the original function, what are we going to get? I'm just trying to see if everything is going accordingly. 2x minus 5, okay. Now we substitute these numbers back into our, I'm just trying to see. I'm rushing here, so I can easily make some mistakes. So this, it cannot be. This 5 shouldn't have been this side, so I suppose we have 1 this side and 5 that side. So, and then a plus this side and a minus there, because I can see that there's something that is not tallying. So that means here we're having minus 5 over 3, and then this side we're having x equals to 1. Sorry for that, learners. Okay, now if we are substituting, you can see this already. We've already done f at 1. f at 1 gave us a 0 earlier when we were doing this, so we only need to do f at minus 5 over 3. F at minus 5 over 3, what do we get? Minus 5 over 3 cubed plus minus 5 over 3 squared minus 5 into minus 5 over 3 plus 3. Now, if we are taking our calculators and punch that quickly, then we will be having minus 5 over 3 out cubed plus minus 5 over 3 squared, and then minus 5 into minus 5 over 3 plus 3. So the answer that I'm having, I believe that you're also getting the same answer, 256 over 27. So that means our coordinates for our turning points, when x, the smallest one, when x was 5 over 3, then our corresponding y is 256 over 27. And again, when x is 1, then the corresponding y is 0. The next thing now, we can just draw our graph. Drawing our graph with all the information that we have done, our turning point is at minus 5 over 3 and 1. If we say this one is 1, then using the same scale, so 5 over 3 is roughly 1,7. 1,7 can be somewhere there. Then that means our graph will be turning up there. And then we'll be going like this, and then filling in all these gaps, then we'll be having a graph like that. And then this is our turning point there, and this point here will be 1 and 0, and then we have our x-intercept. Remember, when we are factorizing this function, we got x plus 3 and x minus 1. So that means this point here is minus 3 and 0. And then our y-intercept will be, if we know that when we're calculating the y-intercept, we always make x 0. So into in this function again, that is a 0 and a 3. So that's all, learners, that you would needed to do to draw this function. That was 7 marks in the question. So to get all that 7 marks, you needed to do all of this. Now quickly, 1.2.2. For which values for which value or values of x is f of x increasing? Remember, learners, now if once we have the graph, it is easier to answer that question. 1.2.2. You can see the graph there is increasing from minus infinity to the turning point. That means the solution to this, when we want to find the value of x where the function is increasing, is x an element of real numbers such that x is less than, what is this value there? Is that value of the turning point, minus 5 over 3. Or when you read it from this point onwards, you can see the graph is decreasing. We want where the graph is increasing. And also from there, at this coordinate of the turning point going to positive infinity, the graph is increasing. That means x greater than 1. So our function is increasing there. Let's see if we can do 1.2.3. Describe one transformation that when applied will result in f of x having 2 unequal positive real roots. If we have to have 2 positive real roots, remember here we're having only 1. Now if we are shifting this function, let's say shifting it 2 units down, it will be at 1 here. So this point will be there. You can see that we're shifting everything downwards. We'll be having 2 positive real roots. But if you shift it further to 3 units down, we'll be having 1 positive real roots. If you keep on shifting it downwards, you'll be having only 1. So that means there is a limit. So if we're shifting this graph less than 3 units, then we'll always have 2 positive roots. If we are looking at 1, I'm just trying to run through everything, but I don't think I will be able in the time that we are given. Let's just, learners, this time I've already having an indication that our time unfortunately has come to an end. It is always exciting and very nice to do mathematics. You can do one problem and then you'll find out that you have spent almost an hour or 2 hours without you even realizing it. Learners, with this information that we have done, just showing you the basics of how to factorize a cubic function and how do you apply calculus. I believe that you can take this information, you can even apply it even to the bigger problems whereby you have to do the optimization on the volumes and the total surface areas. It's the same kind of information, because once you want to find the optimization or the maximum of the volume, the minimum of the total surface area, you just do the first derivative, you equate it to 0. Those x values that you get there, they will be the dimensions that will ensure the maximum or the minima that has been asked. And also, learners, I would urge you that you pay a peculiar attention to calculus, because calculus is very heavy on paper 1, also with functions. But there are a lot of marks that you can get on calculus by only you make sure that you are able to do the first derivative, to do also the rules. Even if you don't know, maybe even if you don't know how to do the application, but those things, make sure that you know. Okay, with me, with all that has been done, let me say goodbye, learners, till we see each other again. Thank you.